So we are starting with the logistic regression analysis output. We try to interpret it here and there, then from there we can continue with the survival analysis. So I'm sure tuliendelea mpaka wapi? Let me check. Up to this point, right? So we were able to get these results, sindio? Brian, are you able to get this output from your side?
Yeah, I got it.
Okay, very good. So we are going to interpret this model, then from there tutakuwa sawa. So the first output is a case processing summary, this output here, and let's check the interpretation. And before we continue, remember logistic regression analysis is used for binary words, for binary regression analysis, or you want to come up with a regression analysis that uses binary outcome, either yes or no, 1 or 2. Yeah, so that is it. Let's try to interpret and understand these outputs. So the first one is just a case summary, the case processing summary. So from this case processing summary, we have values that are included in analysis. There are 20. We had no missing value, and the total is 20. So we recorded 100% sample being included. So our data did not have any missing case. So basically that's what case processing summary means. We have independent variable encoding. This box here, or this table, will guide you or will tell you from the dependent variables, our SPSS considers a yes as 0 and 1 as no. So you remember we code this using SPSS, right? Mnakumbuka venye tulikuwa tuna code these ones? Brian, do you remember?
Yes.
Okay, very good. Well, you define them when you are defining variable. You unatumia hapa kwa the values that you want to include in your variable description, then it will be automatically captured. So these are, let's check what I documented here. So based on this table, this is a case summary table which provides the information about the number and percentages of cases being included and excluded in the logistic regression model. So in a specific analysis, there were 20 cases, as we have seen, and all 20 cases were selected and included in the analysis. Sindio? Stima Mungu wangu. Let's continue. So let's continue. Let's continue with the interpretation. So this is the case summary. So this is the case summary. We have the categorical variable coding. This table ni yenye umepata hapa, this one. That table represents this one here. So and let me check. Yeah, we have the block 0, the beginning block. These are classification table. We have the classification table where we have the observed heart disease, yes or no. Heart disease. Okay, this table basically provides information about the heart disease coding. Those who had yes, they were they were we have this how do we interpret this one here? This is no, this is yes and no. Okay, this table will give you information about the cases that were recorded based on whether uh, the person had heart disease or not, based on whether the person had heart disease or not. So these are categorical. Let's see. Categorical. Okay, the classification table will provide the information on the observed and predicted classifications for heart disease. So in step 0 of the analysis, the observed data shows that there were 8 cases correctly classified as 8 diseases. So from this one here, these 8 diseases, right? From 8 diseases, they were correctly classified as heart disease, yes, while 12 cases were correctly classified as no heart disease. So that is for no. The overall percentage of correct classification was 60%, and the note indicates that a constant is included in the model and cat value for the classification set is at 0.5. This percent, there is a value on B part. So yeah, acha tuendelee mpaka tufike kwa the model. We have the variable in the equations. I wanted to check this one here. Variable in equation. This table, variable not in the equation and variable in the equation. Let's interpret this one and the other one here. Let's see. So the variable in equation table displays the logistic regression results for step 0 of the analysis, right? So in this step, there is only one variable included in the equation, which is the constant term. So the estimated coefficient for the constant is 0.405. This value here. This one here. So yeah, is 0.456. The world statistic is 0.789 with 1 degrees of freedom, the DF, and the corresponding p-value is 0.374, indicating that the constant term is not statistically significant, because it's beyond the threshold of 0.05. So the exponential coefficient for the constant is 1.5. This value here, this one here, the exponential coefficient is 1.5, which represent the odd ratios associated with the constant term in the logistic regression model. So now the variable not in equation, this table, the second table here, the variable not in the equation, the variable not in the equation table, this one represents the statistical information of the variable that were not included in step 0 of the logistic regression analysis, and the table will display the variable age, weight, and gender, and VO2 marks. So for each variable, the table shows the score, degrees of freedom, that's the DF, and the P values. And the P values, the significance, right? The significance value. Now, for age, the score is this one, degrees of freedom is 1, associated with the p-value of 0.23. So we can only compute the 0.05 is not statistically significant in predicting outcome in step 0. Similarly, with the weight, the p-value is 0.914, indicating that the weight is also not a significant predictor. The variable gender has a score of this one, and the p-value is 0.199, also not statistically significant. Lastly, the VO2 max has a score of 0.312 with 1 degrees of freedom and a p-value of 0.577, indicating that it's not a significant predictor either. Yeah. So the overall statistic for the variable not in this equation now is given by the chi-square, the overall chi, the overall chi of 0.476. Friend, are we together? Tuko sawa?
Yes.
Okay, so this is the overall statistic for the variable not in the equation. Shows a chi-square value of 3.513 with 4 degrees of freedom, and the p-value is 0.476. So this suggests that collectively the variables not included in the model do not significantly contribute to the prediction of the outcome. So at least you have an idea of what you expect in the final model, in the final coefficient model. So from this table alone, this variable not included in the model, we can see that they don't have statistically their contributions is not statistically significant in predicting the outcome. So we expect the p-values that are associated with the coefficient to be greater than 0.05. Yeah. So we have method 1, block 1 method. We have the omnibus test of model coefficient. Omnibus test of model coefficient. This is the model summary, and the OSMA and let me show test. Now, how do we interpret the omnibus test? This omnibus test of model coefficient table represents the result of the chi-square test for the overall model in step 1 of the logistic regression analysis. And the chi-square test for the step is the chi-square test. Let me. The chi-square test is statistic, not a test. The chi-square test statistic is 3.922. This value here, the chi-square for step 1 block and the model. But now, what are the significant values? The significance values are 0.417, and ikikuwa greater than 4.05, so this indicates that the addition of the variables in step 1 did not statistically improve the models if it compared to the null model. So at your own time, just go through the steps of analyzing logistic regression model, because tukianzia leo, if we start afresh from zero on how we build the logistic regression model, it'll take time. So It's better you go through it at your own times, and you will understand more or understand it better than when we go through it together. Bearing in mind we don't have that time. Similarly, we have the chi-square test statistic for the block, which basically represents the variables standard on this group as 3.922 with 4 degrees of freedom and p-value of this one. This also suggests that the collective contribution of the variable in step 1 is not statistically significant. Now, what happens if it's statistically significant? If the p-value is less than 0.05, then we include that particular step in the whole process. So the chi-square test statistic for the overall model is now this one, and the associated p-value is 0.417. So this indicates that the overall model, including all the variables in step 1, did not statistically improve the prediction of the outcome compared to the null model. So we have the model summary, this table here, this one, model summary. We have the model summary. What do we have in the model summary? This table will basically give you information about goodness of fit of measure in step 1 of the logistic regression model. So the negative 2 log likelihood value for step 1 is this value here, 22.998, indicating that the overall fit of the model, right? So the cox and the shell r square is 0.178, which represent the proportion of variables in the outcome variable explained by the model. See there. So this model explains what percentage? It explains only 17.8%. The negative r square is 0.241, which is an adjusted version of the cox and shell r square, right? So the notes at the end of the table indicate that the estimation process terminated at iteration number 5 because the parameters estimate changed by less than 0.0001, suggesting that 24.1% from this r square of the variance in the outcome can be accounted for by the predictors included in the first step. So now what about this test, the Osman and Lemeshow test? This test table will provide you with the result of the chi-square test for the overall now goodness of fit of the logistic model in the first step. And remember, this chi-square test is the chi-square statistic is 5.238, and the significance value is 0.735, still not statistically significant. Still not statistically. So the Osmia and the Lemeshow test is used to assess the adequacy of the model in fitting the observed data. So based on the p-value, this model cannot be used to model or fit the observed data. So for this case, the non-significant p-value suggests that there is no evidence to reject the null hypothesis, indicating that the logistic regression model adequately fit the observed data. So therefore, there is no evidence of a lack of fit because the model and the data based on the Osma and Lemeshow test is greater than significance of all the threshold of 0.05. So you can check the null and alternative hypothesis for the Osmer and Lemshow test at your own time. Remember, we fail to reject the null hypothesis because the p-value is not statistically significant. Remember, it's greater than 0.005. 0.005. So we have another table here, the contingency table for Osmer and Lemshow test, together with the classification table. Let's interpret those two, and we see where we are going. So this table, the contingency table for the Osmer and Lemshow test, displays the observed and the expected frequencies of the outcome variable at disease for each group in step 1 of the logistic regression analysis. So the table shows the frequencies of the group where at disease yes and at disease no, as well as their total frequencies. So this is a very simple table. I think you can understand. Okay, this table basically has the observed data and the expected ones. Yes, the expected point based on the observed. So this expected point is how do we calculate expectations? Is observed minus what? Hey. Yes, because you are not doing it manually, just understand the heart disease yes, and the heart disease no. Then from there we have the observed yes values and the expected now. After the model is fitted, we expect to get this point or the estimates. So we expect to get this particular point. So Frinda and others, and Priska and Brianna. I think we are together, right? We have the classification table. Cindy, these are the classification table. So in each group, the observed frequencies represent the actual number of cases observed, while the expected frequencies are the values expected under the assumption of the logistic regression model. So the table suggests a comparison between the observed and expected frequencies for each group. For example, in the heart disease yes group, the observed frequencies range from 0 to 2, while the expected frequency range from 0.138 to these others. So you can go through this interpretation at your own time. It's very straightforward. We have now the coefficients of the model. These are the coefficients of that particular model. And from these values, the logistic regression analysis, you can see in step 1 we have age, weight, gender, and VO2 max plus the constant value. So based on this table, you can write the logistic regression model. Cindy. So okay, can you be able to write this model now? The whole model from this table. Can you be able to write it? Brianna?
Yes.
Can you be able to write the whole model based on these are the betas, and these are the betas, and these are the variables?
Yes.
You can, right?
Yeah.
How will it appear? How will it appear? or what is our dependent, what is our y according to our analysis. Our y is the heart disease, right? I think here ndio unaangalia hapa unakosa. Why is the heart disease? So heart disease is equals to this times this, sindio? Plus weight times its coefficient plus gender times its coefficient, VO2 max plus it times its coefficient plus the constant terms, sindio? Sindio Brianna?
Yes.
Priska? Priska?
Yes, mwalimu.
You can be able to write the coefficient, the model from this one, sindio?
Mm-hmm. Unless I do it practically, yes.
So we were trying to predict the heart disease, yes, right? So from the
Yeah.
heart disease, these are the values, these are the variables together with their coefficients, you know? So you can just write in direct, you know?
Yeah.
Yeah, and you can tell which variable has effect, or a variable which its effect is as
Hi.
statistical. Yes, as is high. The effect is high on
Yeah.
that particular model based on
The coefficients
coefficient
and
the
their significance.
yes, and the significance. So remember, significance is our p-value, sindio?
Yeah.
Yeah. So ukitumia p-value, you can tell which variable has effect, and the effect is statistically significant, sindio? Yeah. So based
Yeah.
on these significant values, okay, let's interpret what is here. So the variable E in the equation table represents the coefficient that is B, betas, standard errors the SE, while the statistic, degrees of freedom the DF, p-value or the significance values, and odd ratios or the expected values of B for the predictor variables in step 1 of the logistic regression model. So in step 1, the predictor variable included in the model are age, weight, gender, VO2 max, blah blah blah, all those. So similarly, the coefficient for weight is this one, VO2 max is this one, and they are not statistically significant because their p-values are greater than 0.05. So you can go through those other points, and you'll see they are not statistically significant. So that is how we interpret logistic regression model. Sawa sawa. That is it. Now, let's dive on what we were supposed to cover today. Today we are doing the survival analysis. I'm sure you this concept is not new to you. We did it in Stata, so it would just be a walk of a single. And remember the okay. What's survival analysis? One of you to tell us a case of survival analysis where you can apply survival analysis. Priska, tunaweza tumia survival analysis wapi? Nani ako na idea where can we apply the survival analysis concepts? Frinda? Frinda, any idea?
Can I try?
Yes.
Can it be done maybe in an event?
Elaborate more.
Maybe by getting, for example, you want to do a study case of something,
Yes.
then you get the population of the people and what they are doing,
Uh-huh.
maybe in time and what they conduct.
I'm going to try. So, um, I can add something in your thoughts, or in your decision, or in your view.
Mm-hmm.
So, if you want to do survival analysis, for example, in an event, it's the same that you have talked about, on what people
Mm-hmm.
they are doing. See there. Now,
Yeah.
suppose these people they are printing papers or they are digging a shamba. See there. So we
Yeah.
can apply survival analysis to tell when we expect them to finish their job. See there.
Okay. Now the duration.
The duration. See there. And
Okay. Yeah.
in that duration we expect so many things. Kunaweza nyesha au watu waache kulima hapo, si ndio?
Yeah.
So hiyo tunasema hiyo iko censored, si ndio? So tunasema the process has been terminated. Sawa sawa. So hiyo ndio concept ya
Mm-hmm.
survival analysis. Or in a business situation, you can apply survival analysis to tell when is when will you be able to meet the target. Si ndio? The target of your business. It will take you how long? Or it will take you how long for your business to close. Unaweza kuwa unapata hasara on daily basis, so you can apply survival analysis ili ujue to estimate the approximate time that you can use to to end the process, to end a certain process, you know. So
Yeah.
yeah, so those are some of the
So for
concepts.
example,
Uh-huh. For
like the
example,
way you have said the business,
yes, for
now
example.
that you have said the business,
Uh-huh.
then we check the perspective of somebody starting a business, the duration that he maybe he took a loan, the duration it will take to repay the loan,
Yes,
and the duration that the business will pick and earn a profit within a certain period of time.
yes, that is survival analysis.
Okay.
Yeah. So let's continue. What? Stima imenionyesha mambo. uh, so these are, we will see how to run the survival analysis test in SPSS and how to interpret the results. Sawa sawa. And survival analysis is one of the advanced research methods used in many different sciences. That is to say, the name of this method reflects the beginning of the medical and demographic studies of mortality. So, in addition, the following introduction of the propositional hazard model by Cox in 1972, the empirical analysis of event history data has become more popular and has become even more widespread. Now, survival analysis is a part of statistics that will deal with analysis of time until an event occurs, right? To clarify, the subject of observations is a variable that having a positive value such as time in death, in medicine, length of stay in the hospital, time to recovery when receiving some therapy, or in the economy, strike duration, right? Unemployment, etc. What are the assumptions that comes with this type of analysis? Now, number one, number one, we expect that the event status or the sensor of event two are mutually exclusive states, and you will understand what you mean by this when when we will be implementing it in SPSS. The survival time, we expect that time to an event of censorship, or we expect, we assume that this event takes a certain time. So no. Yeah, so that is the survival time. For example, when a woman is expectant, we expect survival time for an unborn child to be 9 months. You know? So anything that occurs between if birth of the child occurs before the 9th month, then the process is not complete. That's what we mean. We assume that there is independence of censoring and the event. So we don't expect the duration of 9 months when a woman is expectant. We don't expect that time to depend on the previous pregnancies. You know, so anything can happen. That's what we mean by independence. A similar amount and pattern of censorship per group. So we expect them to have similar amount of pattern. So these are the example that we are going to cover, and this guide will explain step by step how to run survival analysis test in SPSS by using this example. A researcher wanted to examine factors that are associated with alcohol relapse, right? Therefore, they had two groups of people, and the first group was people who were submitted to detoxification, and the second group was people who were submitted to another treatment. Finally, we define the survival time to elapse as the number of days from detoxification or hospitalizations until the onset of drinking. So this is the data. I hope you have loaded the data in your machines. See there. So this is the data that we have. We have the ID. We have the ID of patient. We have weeks, right? We have weeks of conceptions. We have event. We have event and censored. We have then groups. Those who used detoxification and others used treatment. So this is the kind of data that we want to carry a survival analysis on. So you just click on analyze. Click on analyze. Click on survival analysis. Survival. And we are using the Kaplan-Meier estimator. Click on Kaplan-Meier estimator. Click on Kaplan-Meier estimator. I want you to bring, let me reset these ones here. Week, event, and group. So week, bring week on time, event on status, and then group on the factor. I want you to define the event here. So click on event and click on define event. I want only where we have event. So I want where we have only event. Okay, when you click this one here, remember our event is event imekuwa represented with which figure, 0 or 1. Nataka kuona kama tuko pamoja. Event is 0 or 1. Yes. Event is 0 or 1.
1.
1, sindio? So click on 1. Sawa. So click on 1. So under survival, Kaplan-Meier estimator. So on defining event, click 1. So insert 1 and click continue. Click continue. From there, what else are we doing? We are going to, let me close that one. Compare factors. So we want to compare factors. So click on compare factors. Click on compare factors and check the log rank box. So are we together? From there, just click continue. Click continue. What else is remaining? Let's see. From there, click options and check the box for survival tables, mean and median survival, and under plot you mark on the survival.
I have a question, please.
Yes?
I am lost at the back. From the button, are we clicking on analyze or direct marketing?
Which one? The
From the
factor.
start.
From the start. So we start afresh. Okay.
No, they just direct me.
Okay, I want you to begin here. So click on analyze, survival,
Okay.
Kaplan-Meier, sawa. So we bring weeks on time, unaona, event on
Mm,
status, and group on factors. Sawa. Just click on
yeah.
event and define event as 1. We want where we have an event, let's see, not to 1, sawa. Then click continue. Are we together? From there,
Yes.
click on compare factors and mark this box for log rank. Check on it, then click continue. Are we together? Tuko pamoja kweli? Are we together?
Yes, yes.
Okay, click on options. Sawa. I want you
Option, yes.
I want you to check this box. So mark survival tables, mean and median survival,
Mean.
and this one plot and a plot mark survival. Sawa.
Okay. Yeah.
Then click continue and click OK.
Mine
Tuko
is not giving an option of okay.
guy. Kwa nini? Kwa the dialog box haina option ya okay.
The okay is not activated.
It means something has not been done. So just to try to share with us your screen.
Are you guys seeing my screen?
Not really. Share. Let me stop sharing mine. Okay, share now. You can share now. Oh, yes. Click on continue.
And then I went to
Yes,
option.
you have not defined the event. Just click continue. Hapo tu ukiwa hapo kwa Kaplan-Meier. Okay, click on event. Hiyo iko na question mark. click that one.
This one.
No. Yes, that one. Okay, define. Click define event. Hii iko hapo chini yake tu pale umegusa. Define event. Yeah. Insert 1 on the significance value. Andika 1. Then continue.
Yeah.
Then click OK.
Yeah, okay.
Imefungua, si ndio?
Yeah.
Enda kwa hiyo window sasa ya output, then from there we can continue.
Okay, that is how it looks like.
Kwa kuna table unapaswa kupata the output, si ndio? Where's your output window?
This one, the one that has
Tables.
the tables, yeah.
Yes.
The one I'm highlighting right now.
No. Okay, I want you to click on peleka kasa yako hapo tu chini kwa toolbar. Kwa toolbar ya your laptop, uwekelee hiyo kasa yako kwa hiyo SPSS. Utaona kuna option ya ku open the data or the output.
Okay, let me do it.
Let me share with you my screen so that you can see what I am doing.
Okay.
So check this. So nikipeleka my cursor on this side here, so niko na option either ya view the data or this other. So click on that one. Utapata this kind of tables hapo. Sawa. Are we together?
So we are together.
Okay.
Actually, I was in that table.
So ulikuwa kwa kitu kama hisi ndio?
Nilikuwa tu kwa table kama hiyo.
Okay. That's good. So let's now interpret. Tukiinterpreti tutakuwa tumemaliza. Ebu imagine yesterday we bounced our class because of tulikata our class short because of electricity and blackout. So place yenye niko, I'm experiencing the same issue. Ukiangalia my machine right now is 11%. Sijui estimate around saa ngapi, but what's remaining is just interpreting the Kaplan-Meier curve, si ndio? So these are the output now. This is the output discussions. So based on this provided case summary, case processing summary for survival analysis, we have two groups, that's the detoxification and treatment, and here is how you can interpret these results. So hey, Monano, what is happening on my side? What should we do? Your views, what should we do?
Maybe we reschedule the class.
But today is the final day. What is remaining is just interpretations, si ndio?
Yeah.
So yenye imebaki tu ni interpretations pekee. These interpretations, and they are very straightforward. They are how many lines? 5 lines, si ndio? I think for these ones you can go through this at your own time.